Okay, let's start. So hi everyone. Welcome to Overmark's Head Start program. My name is Charlene. Okay, and I am Overmark's resident, I guess, A-levels H2 math tutor. I also teach H1 math. And I've been teaching for about 5 to 6 years now. I give group tuitions, right? Both private and group tuitions. And I also host crash courses. And we hosted one in 2021, right? For those people who are preparing for their A-levels. So I taught the math crash course. And other things about me, I just graduated from NUS Engineering. So if anyone is interested in, I guess, engineering, right, I want to find out more about it, feel free to ask questions in the chat. So as I mentioned, you can enter your questions into the chat, right? I have it open at all times. And as and when, I'll try and answer your questions. If I miss out your question, do ping me again. And there's a Q&A section at the back where I'll be answering most of your questions, okay? Okay, so today's agenda, what are we doing today, right? Basically, we are gonna have an overview. Okay, so I have a question that just came in. Does this course require JC1 knowledge? No, it does not. Yeah, it does not. So overview, we will be taking a look at upcoming topics that you have in J2 and what are the harder topics. I wouldn't say hardest, but harder topics to look out for. Some revision strategy and tips, okay? And the topic covered will be P&C, so permutation and combination. And I will bring you through a rough, I guess, very high level timeline, right, of what is to come till your A-levels in November. Okay, so someone has also asked me, do I teach 2022 J1 H2 Math students? Yes, I do. And I will tell you more about it at the end of the session, okay? All right, so before we begin, just to get a sense, right, of who we have on the call, I have a quick poll. So just want to get to know you guys a bit better, right? Are you J1 or J2? So I'll wait for your answers. Okay, so I see we have actually most people are J1 over here. Welcome. And I guess that means that you are J2 next year, right? Okay. Nice. Okay, so we have most people who are J1. No worries, right? This course P&C is a sort of quite a standalone topic. You don't need any prerequisite knowledge. So yeah, let's just dive in. So the first thing on the agenda is for me to give you an overview of what is to come next year. So for most of you, right, everybody comes from different schools and different schools teach very differently actually. Most of you would have completed vectors, equations and inequalities, functions and graphs, right? Most of you will have also completed differentiation, your APGP or summation, right? Differentiation applications. Some of you may have even touched Maclaurin series a bit and integration, right? But in general, right, okay, for J2, what is covered? We have your Maclaurin series, if you haven't covered it yet. Integration and its applications, if you haven't covered it yet. Differential equations, okay. Complex numbers. Then we have permutation and combinations, probability, binomial and normal distribution, sampling and hypotesting, and correlation and regression. So for the past, I think 2 years, right, because of COVID, they took out the last topic, which is correlation and regression. which I find quite a pity because I think that is one of the easier topics for JC math actually. Yeah. Okay, so just to give you an idea, right? These topics, right? Very ugly, wait. These topics are actually what is known as your statistics. Okay, so everything that you have learned in J1, right? And including these topics that I have not boxed up, right? This is what we know as pure math. Okay, plus your J1 topics. This is your pure math. Okay, why is this important to know? Basically, in your A levels, you need to know how it's broken down, right? In your A levels, okay, your paper 1, your pure math is 100%. Okay, this is 3 hours long. In your paper 2, 40% comes from pure math, and then the remaining 60% actually comes from statistics, and this too is also 3 hours long. So in general, I would say your statistics, right, is easier than your pure math because many people don't like vectors, complex numbers, okay? And in general, all the differentiation and integration. But this one is very, very straightforward. So if you can, try and score in this area, right? As in definitely everyone will be trying to score in this area, right? To pull up their grade. But that also means that the bell curve will work against you for this. So you have to get statistics right. Okay? Pure math is of course very important as well. As you can see, it's basically 140 marks, right? Out of the 200 mark paper. And another thing that I want to say is also time management. So for each paper, you only have 3 hours, okay? Manage your time wisely. So what I mean by this is for paper 2, what I usually do is I do the statistics first. So this 60 marks, I grab everything I can first because it's really easier, right? And very straightforward. Then I will do the pure math. For paper 1, okay, it's really just pure math. So if you don't know a question, immediately skip it, right? Go to the next question already. You don't have much time in the paper, so don't linger on each question for too long. Okay? Okay, so this is an overview of next year's, what is to come for next year, right? Next year's topics. Now I want to talk a bit about the very, I guess the harder topics, right, that you'll face next year. So I'm very sure all of you would have in J1 already experienced, right? Vectors is very difficult, right? And then some of you don't really like differentiation, as well as integration, right? And then a lot of you don't like APGP, those contextual questions, right? I think what I have to say is in math, really, right, practice makes perfect, okay? But let's look a bit at what's to come for next year, okay? So for next year, differential equations, okay? Usually, differential equations comes out as one very, very big question, right? And in this question, there is a mix of differentiation, integration, and a bit of like the application side of things, okay? So this is quite important. I would say it's about maybe 5 to 7% weightage of your paper, yeah? Of course, not as much as your vectors, right? So your vectors is about maybe 10 to even like 12% of your paper usually. But differential equations still makes up a substantial part of your paper. Okay. Then we have complex numbers. This is also about 5 to 10% of the paper. Okay. And this is actually very similar to algebra. In complex numbers, we introduce this new number, okay, is an imaginary number, I, which is actually equal to -1. And you'll see applications for this in complex numbers. Okay, So I won't dive deep into this, but in general, you just need to know that these two are the topics to look out for, along with, okay, many people also don't like permutation and combinations, which is the topic that we're going through today, as well as probability. So these two topics, right, are super duper related, right, and often, right, tested together. Actually, everything, right, in your statistics portion of the paper, right, is sort of tested together, okay? Like you see over here, your binomial and normal distribution. This is a prerequisite for sampling and hypothesis testing, which are two other topics that you'll be taught next year, right? And these two topics, sampling and hypothesis testing, are also related. Sometimes they also test binomial and normal distribution together, okay? So what is difficult about permutation and combination and probability first? Number one, there's many question types. And usually it's all contextual. Okay. So for this, really practice makes perfect, right? You need to be able to recognize the patterns. Okay. For binomial and normal distribution, I think the trouble is that people get very confused between the two. Okay. They don't know how to distinguish between the two. And yeah, usually I'll teach my students a very easy way to remember. And for sampling and hypothesis testing, this is really just, it's not difficult. Okay, that's why it's not recognized as a difficult topic, right? For this two, really just memorization. So in essence, right, for statistics, you can see everything as like interlinked to one another. And that is part of the struggle as well, right? That's when most students get confused, okay? But for differential equations and complex numbers, it's really just learning these new concepts, right? Okay, differential equations, because there's so many things, right, over here mixed together. That's what makes it challenging. Yeah. So these are things to look out for as you progress to, I guess, J2, right? And yeah, what is to come? Okay, let me just admit more people into the room. Okay, so for those of you that just joined, we're just going through the topics now, okay, that you'll be facing in J2, right? Okay. And what to look out for each topic. If you have any questions, feel free to put them in the chat. Yeah. And I just received another question. Hi, will we receive a set of these notes? I can definitely send it on the Overmark general, I guess, A-level channel, right? Okay. If you're in the Telegram chat, then you can receive the notes. Do you guys need a link to the Telegram chat? Let me send it here. Give me a minute. Okay. So I've just sent the link to our Telegram channel, okay, on the chat. So feel free to subscribe, right? I will be uploading this set of notes there at the end of the session. Yeah? Okay. So that's an overview of what is to come. Now talking a bit about your revision strategy, okay? I think we all know for math, it's really impossible for you to just read and understand and then be able to go in the exam and do the questions, right? So what do you need to do? Of course, all the things that's not in your MF26, go and memorize, okay? But on top of that, really practice makes perfect, right? So for me and my students, what I do is in the first year of JC, right? I give them, I guess, notes and worksheets, yes, and we do questions from the worksheets, but I also make sure that they attempt questions from the TYS. And we make sure to buy the topical TYS, okay? So by the time, right, J2 comes around and they buy the yearly TYS, okay, they've already completed the TYS once. So by A levels, you will have completed the TYS 2 times already, okay? So start doing your TYS as soon as possible. get used to the kind of questions that they test at A-levels, right? And make sure, don't just do the questions, right? Make sure you review your mistakes. If you get something wrong, okay, if I were you, I would redo the question and see whether I can do it again, right? But also try similar questions, other similar questions. And this one, I think you can get questions from your school, right? You have your revision packages, or you can get questions from your tuition teacher or just your school teacher as well, right? Okay. And then do your corrections and just keep reviewing, right? And practice really makes perfect, okay? Other than that, every few weeks with my students, I also do quizzes. So this helps them, okay, test their knowledge, right? Not just that, right? Okay, really practice on that time management. And because it's a quiz, they can't refer to the notes, so it helps you memorize the concepts and memorize the equations much, much better. So if you don't have tuition, it's okay, right? Okay, feel free to do that to yourself, for yourself at home. Just take, I guess, one question, okay? In general, each mark, right? 1 mark, I give my students 1.8 minutes. So if you have 10 marks, it's a 10-mark question, it will be 18 minutes lah. So you can use this to go and help yourself, time yourself, right? Okay, at home, or I guess if you have a tutor, right? Feel free to do that. Ask your tutor to do this with you. Or I guess you can join my tuition class. Yeah. Okay. Okay, that's so weird. Do you all see a blue line on the screen? I think it's an annotation. Let me just clear all drawings. Yeah. Okay. Moving on. Okay, please try to not I guess anyhow annotate right on the screen, okay guys? That's quite funny though. What a jokester. Okay, but anyway, moving on. Some more important tips, okay? Get your foundational topics right, meaning if you want to do well in differential equations, make sure your differentiation and integration are solid, right? Practice makes perfect, okay? If you want to do well in, I guess, sampling and hypothesis testing, I would say really get your binomial and normal distribution right. And in fact, if you want to do well in binomial and normal distribution, sometimes you even need probability and PNC. So everything is interlinked. Get the foundational topics right first, and really like the foundational understanding, right? Get that right first. Okay. Number 2, clarify your doubts early. The minute you have questions, don't let it fester, because you will just have more and more questions, right? That's just how A-levels is built. You have 2 years, and there's so much to study in these 2 years, okay? So don't wait, okay? The minute you have a question, ask your teacher, ask your friends even, right? And you can even like co-study together, right? You time your friend times you, and you help each other mark your papers. I think that's a very healthy like sort of friendship to have, right? Okay. And the third point is to be consistent. So don't procrastinate, right? If you need to do the paper, do it, right? Be a bit more disciplined, because A-levels is really not easy, right? And really looking at the runway that you have, you only have about not even a year, okay? You have about 10 months left, okay? And if you are looking just at your prelims, right? Your prelims is in September. You have about 8 months left there, and everything will be tested in your prelims. So try and be consistent from now on. Maybe you do like, even if you do just 1 math question a day, or 2 math questions every 2 days, something like that, right? It's better than nothing. So the trick is to just get started. Okay. So someone just asked me a question. What are the foundational topics? Okay, honestly, I would say, right, vectors is not linked to anything. But before you do anything else, please go and get your vectors right. Okay, so vectors, you know that it's split into 3 parts, right? Get your vectors 1 and 2 right. before you go into vectors number 3, which is the planes part. So before you go into planes, get your points and lines right. So that's what we mean by that, okay? So this is a super duper important topic, yeah? The next thing would be your, I'm a bit biased, right? So I would say everything is important, but the less important ones would be like your equation, right? And inequality, right? And then your functions. I would say this is more important than your equation and inequality, okay? Because always comes out, right? And then your graphing, right? Also a bit more important. Of course, your APGP, summation. Okay, so all this, right, is interlinked as well, right? Actually, I would say this tree is interlinked. You can sort of start to group your topics actually. You will see that APGP and summation is like one group. All this can be one group, right? Your vectors is just by itself. Another topic by itself is your complex numbers by itself. Okay, then what else? We have all the differentiation. So you see, I would say, right, differentiation is a foundational topic along with integration. You need to be able to differentiate and integrate very well in order for you to do many other things. And what are these other things? Of course, it's the applications. Of course, it's your Maclaurin. Okay. Of course, it's your differential equations. This one very important. Okay. So this is like overview of pure math, right? And then you have your statistics. So your statistics, the foundational topics will be your P&C and probability, which you need for everything else. Then binomial and normal distribution, quite new, right? That one really, your GC skills have to be quite good, as in graphing calculator skills. Okay, so an overview again of the topics. If you ask me to pick a few topics to focus on, right? If you really have to, and I don't encourage this, go and focus on your vectors, your differentiation and integration, right? And everything that is linked to it, as well as your statistics in general. Because statistics is so easy. Okay? Okay. Oh, someone is in the room. Let me admit them. Okay, so let's jump in. Okay, we are going to do permutation and combination. I'm going to use the curated notes, and these are the notes that curated for you guys, right? You can purchase them on the Overmark website, okay? Or I guess you can, you can wait for the QR code. There's a QR code at the end of the lesson, right? To go and purchase these curated notes, okay? But this also to let you get a sense of, what is in the curated notes, okay? So the curated notes are written by the tutors. So H2 Math will be written by me, okay? And it's really a condensed version of everything you need to know about each chapter, right? So let's get started and do the one for P&C first, okay? P&C stands for permutation and combination. Okay. I'm sure, right, many of you will have already sort of learned this a bit, right? Okay. In secondary school, when you learn probability, just a bit. Okay. So there's two principles. Okay, there's two. There's two principles that you need to know. And the first principle is the addition principle. Okay. So for the addition principle, right, it is for mutually exclusive events. Okay. So a mutually exclusive event is if the two events cannot both occur at the same time. And what does the Venn diagram for this look like? Like that. There's no overlap. Okay? Cannot occur at same time. Okay? So two mutually exclusive events, right? If the first event has X outcomes and the second event has Y outcomes, okay, so if this has X outcomes and this has Y outcomes, okay, it can happen in X plus Y ways. So that's why it's called the addition principle. Okay, so let's understand this in context. Imagine you are going home from school and there are two bus routes you can take. It's either, okay, it's either you take the MRT, okay, or if you're really lazy, okay, then you can take Grab, or you can take the two bus routes. Okay, so what is the total number of ways to get home? 2 plus 1 plus 1. So there's 4 ways to get home. So this is the addition principle in context. Okay, because if you take Grab, it means that you cannot take MRT already. That's why they are mutually exclusive. So you can think of it this way. So for P and C, right, okay, this is just the principles they need to learn first before we can apply in the question, okay? The second principle that we will talk about is the multiplication principle. So addition principle is plus together. Of course, multiplication principle is you times together. You can see over here. Multiplication. And this is the second principle. Okay. So this multiplication principle is for two independent events. Okay. And they are said to be independent if one event has no connection to the other's chances of happening. Okay. So what do we mean by this? Let's understand in context first. So imagine after school now, right? You decide to take a bus and then you want to walk home. But there are two bus routes, okay? And then there are 3 paths that you can walk, right, in order for you to get home. So for this, right, because it's dependent, it's independent, right? You take bus already, you reach the same bus stop. And then after that, from there, then after that, you decide, right? There are 3 different paths that you can take. So each decision is independent, right? First, you decide which bus to take. Then you decide which path to take, right? So the number of ways for you to get home according to multiplication principle will be 2 bus routes and then times 3 ways, 3 pathways. So total of 6 ways for you to get home. So this is the multiplication principle. So it's very clear, right? The difference between them. One is, the first one, addition is, if I do one of the choices, if I make one of the choices, I cannot make the other choices already. Right? Totally not related, mutually exclusive events. But for this one, multiplication principle, right, is the decisions that are different, but they are connected somehow, right? As in, so they are independent events, okay? So one event has no connection to the other's chances of happening. So if I take the bus route, does that mean that each of the path, right, I have I guess, different probability, right, of taking path 1, 2, or 3, okay? So the total number of ways will be 2 times 3. Okay, so that's the first 2 principles. Now let's jump in, right? Okay, what is permutation? Okay, so we have permutation and combination. A permutation is an arrangement of ordered objects. So if anything you take away from today, right, today's session, just know for permutation, order matters. Okay. So for permutation, this is the symbol, and this can be found in your GC or even in your normal calculator, right? Okay. We have your NPR, and it looks like that, right? Okay, NPR. Okay. And this is actually equal to n factorial over n minus r factorial, where n is the total number of distinct objects and r is the number of objects you actually want to arrange. And something important to note is that 0 factorial is actually equal to 1. So this is just for you to note. Okay, let's look at an example. So how many ways can the word math be arranged? Okay, so because there's 4 letters over here, so the total number of letters is 4, we put that at the top. So it's 4p, and then we want to arrange into 4 different positions because this is 4. Total number of ways, right? How many ways can it be arranged? So you take 4 factorial over 4 minus 4 factorial to get 0 factorial. So at the end, because 0 factorial is equal to 1, you are left with 4 factorial, which is just 24. Okay. And then you can see as well, for example 2, if you have 7 dogs and you want to give 1 to each of your 4 friends, right? Instead of 7p7, now it's 7p4 because you only want to arrange 4 ways. Okay? So it will be 7 factorial over 3 factorial, which will be 840. Or you can just key this 7p4 straight into your calculator. Yeah? So you can read over here, right? Permutation of identical objects. Okay, so before that, right, before I move on, for permutation, just to recap, for permutation, order matters. That's why over here, when we arrange for the friends, right, you must always remember, right, for friends, for anything to do with people, right, it basically usually means that order matters, and that's why you use permutation. Okay, if we have time, we'll be going through a question at the end of the session. Okay, it's a P&C question, so we can do that together. Yeah. Okay. So what if I have identical, right? Identical or repeated objects? Like for instance, in the word overmark, right? What if I have identical objects? In the word overmark, can you see that there are 2 E's, okay, and 2 G's? So if you have identical, then you have to divide by the number of identical. So for this is 2, and then you do a factorial over here. So for this, it will be, we have 10 number of ways, right, to arrange the 10 letters will be 10 factorial, which 10 factorial basically comes from your 10p10, which is 10 factorial over 0 factorial, which is just 10 factorial. Then you need to divide by the 2 identical. So because there's 2 identical O's, you divide by 2 factorial. 2 identical E's, you divide by 2 factorial as well. If you had 3 O's, then you will divide by 3 factorial. Okay? Then you get your final answer. Okay, so slow and steady, right? Okay. Now let's look at another question type. What if they say, how many 4-digit numbers can be formed from this set? And down here, you realize that there's 5 numbers over here. If the digits may be repeated. Okay, so for this, the number of ways will be, because there's 5 numbers, you do 5. And because there's 4 places, you do to the power of 4. Very straightforward. Okay. And in the curated notes, I have more permutation examples over here. Okay. And basically, okay, we will be going through a question at the end, right, of the session. So let's, I guess, let's go through that question, right? This one I will just very briefly go through. Okay. We can come back to this later if we have time. Now I want to talk a bit about circular permutations. So we already learned that for permutations, right, it's basically the n factorial, right? So your npr will be n factorial over n minus r factorial. Okay? But if you are arranging your objects in a circle, right, that means I have friend A over here, friend B over here, friend C over here, let's say. And I want to know the number of ways to arrange them in a circle. The formula you need to use is n minus 1 factorial. So I just received a question. Will this recording be posted on the YouTube channel? Yes, it will be posted on the YouTube channel. I think. I need to ask Daryl actually. But I will ask him if possible to post it on the YouTube channel. Yeah? Okay. So for this case, right, of 3 friends, okay, the ways to arrange them in a circle will be 3 minus 1 factorial, which is 2 factorial, which is just 2. Okay? But if the seats at the round table are numbered, then it will just be your n factorial. So if let's say I say in this circle, right, I have 1, 2, and 3, and the same, I want to arrange my friends A, B, and C here. Instead, it will just be 3 factorial, which is 6. Okay? So you can see here, how many ways can 3 boys and 3 girls be seated at a round table? There's 6 people in total, so it's 6 minus 1 factorial. But what if all 3 girls must sit together? Then what happens, right? So you will group the 3 girls together like this. Okay? And then, okay, this will be seen now as one person. Okay? So because this is 1 person, then we have 1, 2, 3 boys. Now, I will do 4 because there's 4 people altogether minus 1 factorial. So this is to arrange groups at the table. But why do I multiply by this 3 factorial over here? Because I need to arrange the girls in the group. Okay? So that's why your answer will be 3 factorial times 4 minus 1 factorial, which will be 36 in the end. So it's the same, right? If now I say I have 1, 2, 3, 4 boys and 3 girls, and all the boys must be together, right? So I will group the boys together. So this is one group. So I have 1, 2, 3, 4, right? So number of ways to arrange them will be 4 minus 1 factorial times 4 factorial, because I need to arrange the boys in the group. Okay, and then if the seats are numbered, how do I arrange the 6 people? It will just be 6 factorial. So this is circular permutation, okay? And then you can see there's more work examples over here, right? Which if you get the curator notes, you can, I guess, go through yourself, okay? Let's do combination now. So a combination is actually an arrangement of objects, okay? And this one, order does not matter. Okay. So again, okay, if anything you need to take away from this session, it will be that for permutation, order matters, and for combination, order does not matter. Okay, so a combination is an arrangement of objects where order is not taken into consideration. And how is permutation and combinations linked? They're actually linked by this equation over here. Okay, so your permutation is actually your combination, right? Okay, times your n factorial. So total number of objects. Okay. So let's see an example. There are 38 workers in the company. The CEO wants to pick 3 new leaders for the company. How many ways are there to pick the 3 new leaders? So because they use the word pick, we will be doing a combination. So it's literally just out of the 38 workers, I just choose, right? Okay, this is the same as choose. I choose 3 new leaders. So it's 38 C3. So someone is asking, how do we tell if the question is asking for permutation, combination, or both? Very rarely they'll ask for both, okay? But how you distinct between permutation and combination is you ask yourself, does order matter? So take note of the words that are being used, okay, in the question. So for words like pick and choose, it's definitely combination. You can see combination as like choose as well. Okay. For permutation, right? Okay, is if they say, okay, how many ways are there to arrange? So they will use words like arrange or number of ways they can be seated, right? Let's see. Okay, I don't have an example here, but for permutation, yeah, you see they have different arrangements, okay, in the question for permutation. Or how many ways can they be seated? So I think the confusing part, right, okay, is if there's people involved. Okay, so let's go back to this example and let me illustrate what I mean, right? Okay, for this, right, they're just saying, okay, of the 38 people, I just want to pick 3 people to be new leaders, right? And it's just leaders, okay? Like it doesn't matter, right? It doesn't matter how the 3 people are ordered in the leadership. But let's say I say I want to pick 38 workers, right? Okay, 38 workers. I want to pick 1 general manager, 1 maybe 1 secretary, and 1 chairman. So if I have these 3 distinctions, right, then it's very clear I need to arrange the people, right, into these 3 positions. Then for this case, it would be 38 P3 instead of C3. So because P and C has so many different question types, right, very difficult for me to, I guess, tell you, okay, always when this comes out, you will use permutation or combination. So it really depends on the question, but in general, just keep at the top of your mind, right? If you have to pick, right? Okay, for instance, you have to pick the people, pick positions for the people, right? Then you have to use permutation. Versus if you do not have to choose there's no title involved, right? Then you can just use combination. So ask yourself, right? Is the object distinct? Like, can you tell them apart? If you can tell them apart, like for this scenario, then you have to use permutation. If you cannot tell them apart, like the three leaders, it doesn't matter which position they're in, then it's combination. Okay? Hope that answers your question. Moving on. Yeah, so you see over here, how many ways are there to form the committee, right? If there is 3 different positions, then it will be 38 P3 instead. So you can see. Okay? Okay. So this is actually a real prelim example, right? About, I guess, the president's bodyguard, okay, there's 40 men. Then there are 10 experts in firearms, 10 in unarmed combat, 10 in blah, 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 blah. Okay, each has its own specialty. So 10, 10, 10, 10. So each man is an expert in only one area. In preparation for a historical summit, a team of 10 bodyguards, okay, is to be chosen from the 40 men. And there needs to be at least experts from each area. At least 2 experts from each area. Okay, so for this, you will do case by case basis. Okay, so the first case is it comprises of 2 plus 2 plus 3 plus 3. Okay, so for this case, right, you will do out of the 10 in firearms, you choose 2. Out of the 10 in unarmed combat, you choose 2. Out of the 10 in tactical driving, you choose 3. Out of the 10 in first aid, you choose 3. But then, because there's 4 groups of people, so it doesn't have to be 10 from firearms, 10 from unarmed combat, right? It can be 10 from, it doesn't have to be 2 from firearms, 2 from unarmed combat. It can be 2 from tactical driving and 2 from first aid. That's why you have to do this 4 factorial, because you are arranging the groups, the 4 groups of men that there are. And then because you choose 2 for here, you have to divide by 2 factorial. And then because you choose 2 from here, you have to divide by another 2 factorial. Okay? Then the second case, if it's 2, 2, 2, and 4. So again, you have to arrange, right, the 4 groups of men. Okay, that's why you have this 4 factorial. But because these 3 are similar, right, it's choose 2, choose 2, choose 2 from these 3, you have to divide by 3 factorial. Then you add the 2 cases together. Okay? And that's really all for permutation and combination. Just these 2 concepts, right? The first concept that we learned is addition and multiplication principle. Then we learned about what is permutation. And then we learned, right, what is combination over here and how to tell the difference between the 2 of them, right, combination. So permutation order matters, combination order does not matter. Now let's try an example together. Okay, so I'll go back to my notes over here. And we're going to try this example together, okay? So Kiki and Lala host a dinner for 4 other married couples. They sit at a rectangular table with Kiki and Lala on the left and right ends of the table respectively. Okay. Find the number of ways to seat the 4 couples such that there are no restrictions. So I hope, right, okay, the first thing you need to notice, I hope that you can notice, okay, is that this is actually, even though it's a rectangular table, right? Okay, even though it's a table, it is not a circular table, right? So there's literally 1, 2, 3, 4. It's really just 8 positions over here altogether. Okay, so in this case, if there are no restrictions, how can I seat the 4 couples? That means no restrictions, meaning the couples can intermingle, right? Okay, the husband and wife don't need to sit together, right? It really just anything goes. So if there's 8 positions, there's 8 people, it will just be 8 factorial, right? Because it will be 8p8, which will be 8 factorial over 8 minus 8 factorial, which will be 8 factorial over 0 factorial, which is how you get your 8 factorial. And why is it p, right? Why does order matter? Because we are dealing with people. And each couple has probably a distinct name. And if you put Mary here, John here, let's say, right? Okay, it's very different from if you put Mary here and then John over here. So it's very distinct. That's why order matters and you have to do permutation. Okay? So the second part, what if each married couple is seated directly facing each other on opposite sides? Okay? What if each married couple is seated? So that means, right, couple 1 and couple 1, couple 2 and couple 2, they have to sit like that. It can be like that, or you realize it can be 2, 2, 4, 4, 3, 3, and 1, 1, right? There's so many different arrangements, but they all have to be seated opposite to one another. Okay, so this is at the table. So how will we do this? Okay, as I said, you can see this as like one group like that, right? Okay, one group, one group. So altogether, there are 4 groups. Okay, so I need to arrange these 4 groups. So I will do 4 factorial. Okay, and then within each group, can you see that I can arrange the couple as well, right? It can be Mary and John or John and Mary. Husband and wife or wife and husband, right? So within each group, I can arrange them as well. And there are 4 groups, so I will multiply by 2 factorial, multiply by 2 factorial, 2 factorial, and 2 factorial 4 times. Because within each couple, I can arrange them. So this is as good as you saying 4 factorial times 2 factorial to the power of 4. And you should get 384 over here as your final answer. Oh, sorry. So this is for part B. Okay. And for the last part, each married couple is seated directly facing each other on opposite sides. Okay. And 2 particular ladies cannot be seated to each other on the same side. So this one gets a bit tricky, right? But it's okay because you've already done this first part. This is if it's this scenario, right? Each married couple is seated facing opposite each other, directly facing each other on opposite sides, right? Okay, so now you just need to take away the cases that the ladies are seated next to each other. Okay, so for part C, it will be 384 minus, right, the case that the ladies are together. Okay, so this will be 384 minus, okay, so when will the ladies be together? There's 4 ladies, right? Okay. So let's see first, right? Altogether, there's 8 people. If I take away the 2 ladies, I have 6 people left. Okay, so of these 6 people, okay, I'm going to choose one person, okay, to be, okay, I'm going to choose one person, okay, or rather, I'm going to choose one person to be between them, okay. Then, actually, we don't need to do that, sorry. Okay, before we begin, let's arrange the 2 ladies first. Okay, because remember, this is the case that the ladies are together. Okay, so in this case that the ladies are together, right, we will group them together. So let's say it's like lady 1 and lady 2, right? We'll group them together. So we're minusing off the case that they are together. And then the rest of the people, right, can be like here, here, like that. Okay? Or it can be other ways as well, right? Like these 2 can be here as well. Okay, so there's many ways, but it's okay. Whatever it is, the thing that remains constant is what? That the 2 ladies are together. So we will group them first, okay? Basically, yeah, 2 factorial. Okay? Then what happens? There's actually 2 ways to do this, right? Okay, so let's do this way. 2 factorial, you arrange them already. Then let's count how many slots are there, right? For them to be slotted in. So they can be here, here, or here. So that's 3 already, right? So they can be 1, 2, 3. They can be, and then the other side, right? Okay, it will be 3 times 2. Okay, so let's count now. Number of slots, okay? Why? Because we are seeing them as one group, right? So it will be like that, like that, like that. And they are included as one of them, right? So can you see that the 2 ladies, right, can be either here, 1, 2, 3, 4, 5, 6. There's 6 positions for them to be in, right? Because we group them together over here already. Okay, actually, let me draw it this way instead. Over here, right? They can be here, they can be here, or they can be here. But on the other side, on the flip side, okay, if let's say I want my ladies to be on the other side, L1 and L2, then I can only have 2 people here, and then 1, 2, 3, 4. So it's the same. I can only have them here, here, or here. So altogether, there is 6 positions for them to choose from. Okay, that's why I'll multiply by, out of these 6 positions, I'm going to choose 1 slot for them to be in. Okay, so of these 6 positions, I choose 1 slot for the 2 ladies to be together in. And then the rest of the people, I can anyhow arrange them already, right? It doesn't really matter anymore per se. Okay, I have, out of 8 people, I already took away the 2 ladies. So I have 6 people left and I already slotted them in. Okay. Then I can actually arrange them by 6 factorial. Yeah. And that's all actually. So if you calculate this, so you can put it in your GC or your normal calculator, right? Okay. Sorry. I realize that it shouldn't be this way. Because, okay, sorry. Why we cannot do 6 factorial? Because, right, they still have to be directly facing each other on opposite sides. So we cannot anyhow arrange them. Okay. So what does this mean? That means that the two ladies are here. Their husband 1 and husband 2 have to be here as well. So you're also arranging the two husbands actually. You have already arranged them. So what is left is actually the other two couples, right? Okay. So for them, you also have to arrange them, right? The other two couples, you have to do 2 factorial. Okay. To arrange them within each of their groups, and there's 2 of them, right? So you have to multiply by this 2 factorial, so within the group. Okay. Multiply by 2 factorial. And then you can arrange them. So because you are arranging them, right, you are sort of slotting them into the places that are not taken by the two ladies and their husbands. Okay. So you will multiply by 2 because that's the only 2 slots left. Okay, so someone asked me a question. Why do we use choose instead of permutate? Because for this, we are choosing slots for the ladies to be in. So if we look here, right, rather, I have my table over here. If my lady 1 and lady 2 is over here, the husband 1 and husband 2 definitely have to be here. So now we are looking at the cases where these 2 girls are together, but also they are arranged in this way. Okay, so your lady 3 and lady 4 will have to be here, but their husbands will also be here. Sorry. So can you see that, okay, for them, I just need to choose, right? Okay, they are together, ma. I just need to choose the slots that they are in. So this can be 1 slot. Over here can be 1 slot, right? In the middle of this couple, right? So this is 1 slot. This is the 2nd slot. And then over here also can be the 3rd slot. But why is it 6 slots? Because it can be that the lady is on this side as well, and then the husband is on this side. So that's why of the 6 slots, I'm going to choose 1 slot for them to be in. Okay? Does that answer your question? Okay, great. Yeah, so of the 2 ladies, we arrange them, right? Then after that, we multiply by this 6 choose 1. Okay, then we also have to arrange, because when we arrange the 2 ladies, we're also arranging the husbands because it's fixed. They have to be together this way. But we also have to arrange, right, the husband and the ladies for the 3rd and the 4th couple. And then for after, right, we set them, right, there's actually only 2 slots for these 2 people to be in, right? It's either here or here, right? Okay, so that's how we are arranging the groups. So that's why we multiply by 2. Okay, so if you're going to calculate, you will get 384 minus 96, which is 288. So that will be our final answer for this. Okay. I'm going to pause here for questions, just for a minute or so, right? Okay, no questions. Very good. Then let's talk a bit about the key milestones. You have about a year left. Actually, less than a year left to A-levels. So what do you have to expect for next year? Okay. Number one, your mid-year exam in May, right? Where they will test very heavily on your J2 topics. And usually your CCA haven't stand down yet, okay? Then you have your prelims in September. And the entire syllabus will be tested. Get used to the format of the exam, the time management, okay? The third one is A-levels already in November and December, right? Usually for math, it will be early November, okay? And it will last about 4 to 5 weeks, depending on what's your subject combination. Yeah? So really, right, not a lot of time left. Start practicing as soon as you can. And just some food for thought, okay? Where do you see yourself? Sorry, this should be where. Where do you see yourself in 1 year's time? Right? In 1 year's time, do you see yourself as the person who is like last minute mugging, right? And really freaking out, right? Or I'm sure many of you, I'm sure all of us don't see ourselves that way. Or if you see yourself, I guess, prepared for A-levels, right? Actually, in 1 year's time, A-levels will be over. So maybe you have already finished A-levels and you feel like, oh, I really gave it my best, right? Then at your current pace, ask yourself, right, at your current pace, will you be able to achieve your goals that you want to at A-levels, right? Will you be able to achieve that, I guess, that sense of stability after completing A-levels? So that's something that you have to ask yourself. And the next step will be, okay, if I cannot, right, at my current pace, reach my goals, then what do I need to do to reach my goals? What are the milestones I need to achieve, right? What's the work and effort that I need to put in? Maybe you need to come up with a schedule. Maybe you need a new note-taking system. Maybe it's really about scheduling, right? Just putting in the hours of practice every day and booking consultations and whatever it is, right? Okay. So ask yourself these questions, start thinking about your future. In fact, for J2s, right, start thinking about, hey, actually next year, right, after my A-levels, what do I want to do? Do I want to be I don't know, right? Do I want to go to business? Right? Do I want to be a business person? Do I want to, I guess, go into engineering? What do I want to do with my life? Right? Because after A-levels, when your university comes, it's really the most important exam, right? It will determine the rest of your life already. Okay? And yeah, I wish everyone all the best for an exciting year ahead. Really just try your best, right? Don't put too much pressure on yourself, right? Don't stress out too much, but give it your best shot lah, I would say. Okay? Push on, 加油 everyone, okay? And if you are keen, I have a group tuition, right? Max I will take is about 8, right? Okay. Unless it's online tuition. Yeah, but my tuition is 2 hours a week. And we'll go through each topic in detail with worksheets, notes for you, okay? I have a free trial lesson available for J2s, right? This will be online on 2nd of January from 4 to 6 p.m. The one for J1s is on the same day, 2nd of January. Okay, it's 1 to 3 p.m. Okay. And weekly group tuitions, right? It's every Sunday, 4 to 6 p.m. The first lesson will be on 9th of Jan. Okay. Either at Toa Payoh or online. And it will be 50 an hour. Yeah. So the resources you'll get will be like the notes, right? Which I'll print for you, as well as any worksheets, right? Of course, we'll go through the worksheets together. Okay. So feel free to scan the QR code if you want to sign up. And yeah, that's all for today. Okay. So I will be, I guess, on the call until the last person leaves, right? And for another about 10-15 minutes, okay, to answer your questions. I guess before everyone leaves, sorry, help me do a short poll. Okay. Did you find today's session useful? Thank you, everyone. Everyone is like, as in, there's so many people that are annotating. Or I don't know if it's the same person actually. But yeah. Okay, thank you everyone for your answers, right? And yeah, you're free to go unless you have any questions for me. Thank you. Thanks, Liz and G. Hi, do you have any questions? I'll stop sharing my screen. Okay, if you have no questions, I'll end the meeting and end the recording, okay? Okay, I'll end the meeting now. Bye.